the Sun. A colossal sphere of burning plasma, it stands as the very heart of our solar system, a beacon of light and energy that has fascinated humanity for millennia. It's the anchor of our cosmic neighborhood, holding everything from the smallest asteroid to the largest gas giant in its gravitational embrace. This blazing ball of plasma dictates the rhythm of our planet, driving our seasons, weather patterns, and even the very existence of life itself. Its energy fuels the photosynthesis process in plants, which in turn supports the entire food chain. Without the sun's energy, Earth would be a barren, frozen wasteland. The oceans would freeze, the atmosphere would collapse, and life as we know it would cease to exist. We are utterly dependent on its light and warmth. Every sunrise brings a new day, a new opportunity for life to thrive and evolve. But the sun is more than just a life giver. It is a dynamic and complex celestial object, constantly changing and evolving. It is a fascinating celestial object in its own right. Its surface is a turbulent sea of hot plasma, with solar flares and sunspots marking its ever-changing face. It holds secrets about the universe's birth and the processes that create stars. By studying the sun, we gain insights into the formation and evolution of other stars in the cosmos. Understanding the sun is key to understanding our place in the grand cosmic tapestry. Scientists use advanced telescopes and spacecraft to study its behavior and unlock its mysteries. The sun's gravity holds our entire solar system together, from the smallest asteroid to the largest gas giant. Its gravitational pull ensures that planets, moons, and other celestial bodies remain in their orbits. It's a constant presence in our sky, a source of wonder and inspiration for poets, scientists, and dreamers alike. Throughout history, cultures around the world have revered the sun, celebrating its life-giving power through myths, rituals, and art. But even stars have a lifespan. They are born, they live, and eventually they die. The sun is no exception. Let's take a journey to explore the life and death of our very own star, the sun. From its fiery birth in a cloud of gas and dust to its eventual transformation into a red giant and beyond, the sun's story is a testament to the dynamic and ever-changing nature of the universe. Our sun, like all stars, began its life in a stellar nursery. These nurseries are vast regions in space where new stars are born, filled with gas and dust. They are the cradles of stellar creation, where the seeds of future stars are sown. Imagine a vast, cold cloud of gas and dust, a nebula drifting through the cosmos. These nebulae are often dark and cold, but they hold the potential for incredible transformation. Within these clouds, the raw materials for star formation are abundant. Within this cloud, gravity acted as a sculptor, pulling particles together. Gravity is the force that drives the process of star formation, drawing particles closer and closer. As these particles come together, they begin to form clumps, the precursors to stars. Over millions of years, this gravitational pull intensified. The cloud began to contract, and the particles within it started to collide more frequently. This process is slow and gradual, but it is relentless, driven by the unyielding force of gravity. The cloud contracted, pulling more and more material towards its center. As the material gathered, the density at the core of the cloud increased. This central region, where the material was most concentrated, would eventually become the heart of a new star. As material clumped together, collisions became more frequent, generating heat. These collisions released energy, causing the temperature within the cloud to rise. The heat generated by these collisions was a crucial step in the birth of a star. The core of this collapsing cloud grew hotter and denser. As the temperature and pressure increased, the conditions became more extreme. This core, now a protostar, was on the verge of a dramatic transformation. Eventually, the temperature and pressure reached a tipping point. At this critical juncture, the conditions were right for nuclear fusion to begin. This was the moment when the protostar would ignite and become a true star. At this incredible threshold, nuclear fusion ignited in the heart of the young sun. Nuclear fusion is the process that powers stars, where hydrogen atoms are fused together to form helium, releasing vast amounts of energy. Hydrogen atoms, the simplest element in the universe, were forced together under immense pressure. This fusion process is what makes stars shine, converting hydrogen into helium and releasing energy in the form of light and heat. They fused, creating helium and releasing a tremendous amount of energy. This energy radiated outwards, lighting up the surrounding space and marking the birth of a new star. This fusion reaction marked the birth of our star. The sun, now a fully fledged star, began to shine brightly, its energy driving away the remaining gas and dust in the surrounding space. The sun, now a blazing ball of plasma, illuminated its surroundings, pushing away remaining gas and dust. This process cleared the space around the sun, creating a region where planets could form. This cleared a space around the sun, eventually allowing for the formation of the planets, including our own Earth. The material that was not blown away began to coalesce, forming the building blocks of planets. The sun's fiery birth, about 4.6 billion years ago, set the stage for the solar system we know and love. This process of star formation is a testament to the incredible forces at work in the universe, shaping the cosmos and giving rise to the stars and planets that fill our night sky. Stars, like humans, experience a life cycle. They are born, they live, and they eventually die. But unlike humans, a star's lifespan is determined by its mass. It's a cosmic rule of thumb. The more massive the star, the shorter its life. Massive stars are like rock stars, living fast and burning out quickly. They blaze with incredible intensity, consuming their fuel reserves at an alarming rate. Smaller stars, like our sun, are more like marathon runners. They pace themselves, steadily burning their fuel over billions of years. Our sun sits comfortably in the middle of the stellar mass range. It's not a giant, nor is it particularly small. This means it has a respectable lifespan, long enough for life to evolve on at least one of its orbiting planets. We are fortunate to exist during our sun's stable middle age, its main sequence phase. But this stability, like all things in the universe, is temporary. The sun, currently in its main sequence, is a model of stellar stability. It shines brightly in the sky, providing the energy necessary for life on Earth. This phase, known as the main sequence, is characterized by the fusion of hydrogen atoms into helium in the sun's core. This process releases an immense amount of energy, which radiates outward and reaches us as sunlight. It's been fusing hydrogen into helium for billions of years, providing a constant stream of energy. This fusion process is incredibly efficient, allowing the sun to maintain its luminosity and size. Solar flares and sunspots are visible manifestations of the dynamic processes occurring within the sun, but this stable phase won't last forever. As time marches on, the sun will undergo significant changes. The balance between gravitational forces and the pressure from nuclear fusion will eventually shift. Over time, the sun's core will slowly run out of its primary fuel, hydrogen. As the hydrogen supply dwindles, the core will no longer be able to sustain the same level of fusion reactions. As hydrogen becomes scarce, the core will contract and heat up. This contraction increases the core's temperature, leading to the fusion of helium into heavier elements like carbon and oxygen. This increased temperature will cause the outer layers of the sun to expand dramatically. The sun will grow in size, becoming a red giant. Its outer layers will stretch far beyond their current boundaries. The sun will swell into a red giant, engulfing the orbits of Mercury and Venus. These inner planets will be consumed by the expanding sun, their surfaces scorched and vaporized by the intense heat. Earth, if it survives, will be a scorched wasteland. The oceans will boil away, and the atmosphere will be stripped off, leaving a barren, lifeless rock. Following its red giant phase, the sun will shed its outer layers into space, forming a beautiful planetary nebula. This nebula will glow brightly, illuminated by the remaining core of the sun. The core, now a dense ball of mostly carbon and oxygen, will remain. This remnant is known as a white dwarf, a stellar ember left behind after the sun has exhausted its nuclear fuel. This remnant, no longer capable of nuclear fusion, will slowly cool and fade over trillions of years, becoming a white dwarf. It will emit a faint glow as it radiates away its remaining heat. This is the final stage of our sun's life cycle, a dim ember, a testament to its once blazing existence. The sun, which once shone so brightly, will end its days as a faint cooling remnant in the vastness of space, a silent witness to the passage of time. While our sun will end its life relatively peacefully, some stars go out with a bang, literally. Massive stars, much larger than our sun, experience a far more dramatic end to their stellar lives. They explode as supernovae. These explosions are among the most powerful events in the universe. They release an unimaginable amount of energy, briefly outshining entire galaxies. Supernovae are not just destructive forces, they are also the universe's great recyclers. The intense heat and pressure within a supernova forge heavy elements like gold, silver, and even the iron in our blood. These elements are scattered across the cosmos, seeding future generations of stars and planets. While our sun won't experience this explosive fate, we are connected to supernovae. The very elements that make up our bodies were forged in the hearts of these dying stars. As we learn more about the sun's life cycle, it becomes clear that our time on this planet is finite. The Earth will eventually become uninhabitable, long before the sun enters its final stages. This realization underscores the importance of exploring and understanding the universe around us. The search for habitable planets, worlds that could potentially support life, has become a priority for astronomers. Telescopes like the James Webb Space Telescope are peering deep into the cosmos, searching for signs of planets orbiting distant stars. Finding a second home for humanity is a daunting task. The distances involved are vast and the challenges are numerous, but the discovery of even a single habitable world would be a profound achievement. It would demonstrate that we are not alone in the universe and that life may exist beyond our pale blue dot. Standing beneath a starlit sky, it's easy to feel small and insignificant. The universe is vast, ancient, and full of mystery. But we are a part of this universe, connected to it in ways we are only beginning to understand. The story of our sun, from its fiery birth to its eventual demise, is a reminder of the constant cycle of creation and destruction that governs the cosmos. It's a story that fills us with awe and wonder, but also with a sense of responsibility. We have the incredible opportunity to explore the universe, to unravel its secrets, and to search for other life. The journey ahead is long and challenging, but it is a journey worth taking. For in understanding our place in the cosmos, we ultimately learn more about ourselves. And that is a discovery worth celebrating.